Good morning to all of you.
Good morning, sir. Good morning, Chef.
Good morning. Today, our topic is equivalent values of drive parameters. Today, our topic is equivalent values of drive parameter. There are mainly two cases. One load with rotational motion and another is loads with translation motion. First, we consider load with load with rotational motion. First, let me the draw a diagram. This is motor. This is fast load. Start is TL0 and we are rotating with omega m. The total moment of inertia of motor and fast load is J0, and this also rotate with speed omega m. Suppose the number of teeth of that gear is n, and this for this is n1. This is second load. This is our second load. Whose load torque is T uh, 1, basically N, and it rotates with the speed omega n1, and the load torque should be in opposite direction. This should be, so this is diagram for load with rotational motion, and what we consider here, the J0 is, what is J0? Tell me what is J0? What is J0? J0 is moment of inertia of what? Motor and load system. Load 1, like load system, and omega m is angular velocity or you may say this is speed, angular speed of motor, and TL0 is the load torque, and omega m is angular speed of road, which is coupled with the load 1 or motor side. TL1 is load torque of the load coupled through the gear. First, we consider the ratio of the gear teeth. Suppose we have to write now omega m1 by omega m is equal to n by n1 is equal to a. Where is a or what is a? A is gear teeth ratio. A is gear teeth ratio. Have you understand that? Deepak,
Yes sir.
have you understand what we are doing?
सर स्क्रीन शेयर नहीं हो रहा है.
शेयर नहीं हो रहा है. Oh, okay, okay. Let me. First, what we doing that? Our topic is equivalent values of drive parameter. It is shown that the PPT is or screen is sharing or not.
शेयरिंग सर.
Okay. And our topic is the equivalent values of drive parameter. First, we consider low to it rotational motion, and we are taking a motor and load directly coupled, and another load is coupled through a gear system. The gear ratio is called A, where the first uh, gear tooth is N, and we are considering the tooth of second gear is N1. And what we consider again, we say the J0, that is moment of inertia of motor, and the first load is J0. We are considering the moment of inertia of motor, and the load is J0, and the rotation or angular speed of the motor shaft is omega m. We are taking or we are considering that, and the load torque of the first load, which is directly coupled with uh, motor, is called, or we are considering here, TL0, and the angular speed of the load, which is coupled with the coupled through the gear, is considering omega m1, and the load torque of that load, that is which is coupled through the gear, is considered here TL0. Then what we consider, the gear tooth ratio is equal to actually n by n1 is equal to a, and it should be equal to the angular speed ratio of omega n1 to omega m. Up to that, hope you will understand. Up to that, hope you will understand. Deepak, Deepak, am I audible?
यस सर. ऑडिबल सर.
Okay. Hope you will understand that what we are doing or what we try to calculate. the total moment of inertia of that system and the total load torque of that system. We have to calculate these values. This is called the equivalent values drive parameter. So first tell me what is the kinetic energy of total system. Tell me what is the kinetic energy of the total system. What is the formula of kinetic energy?
1 by 2 MVA square.
1 by,
2 MVA square.
if it is in linear motion, then we say that because the mass of that system is m, and if the velocity of linear velocity of that system is v, then we can say that kinetic energy of that system is half mv square. But here we consider the rotational motion. So what should be the kinetic energy formula? Tell me, in case of rotational speed, what should be the formula of kinetic energy? It's similar, or it you can say analogous to the linear system. It is, the formula is half j omega square. The formula is half j omega square. If we consider the total moment of inertia, suppose j is equivalent moment of inertia of the system, then we can write half j omega m square is equal to half j0 omega m square plus half j1 omega m1 square, because the total moment of inertia is equal to the sum of the individual moment of inertia. We can write that. Have you understand that, Deepak?
Yes, sir.
Because we are considering j is equivalent moment of inertia and the system is rotating angular speed of omega m, so we can write the total moment of inertia is equal to sum of individual, sorry, total kinetic energy is equal to sum of individual kinetic energy. What is the formula of kinetic energy? What is the formula of kinetic energy in case of angular system? Half j omega square, and here we taking the speed omega m, so first we write the total kinetic energy is equal to half j omega m square is equal to what is the kinetic energy of motor and first load system. Tell me. Tell me, Deepak. Deepak, am I audible to you?
Yes, sir. Yes, sir. Audible, sir.
Tell me, what is the kinetic energy of that system?
Half J omega square, sir.
We are talking about this system. What is the value of kinetic energy, or what is the formula of kinetic energy of that system? Tell me. Half
J omega square.
J0 omega m square. And
Yes,
what
sir.
is the value of kinetic energy of that system? The load which is coupled with gear to the motor. What is the value of that system? What is the value of kinetic energy of that system? Tell me. What is the value of uh, moment of inertia of that? Can you tell me? If the moment of inertia of that system is J1, then what is the value of kinetic energy of that system?
Half J1 omega m1 square.
Half J1 omega m square. Okay. From this equation, what we get? J omega m square is equal to J0 omega m square plus J1 omega m1 square. We eliminate half from both sides. After that, we write here J is equal to J0 plus J1 omega m1 by omega m whole square. We can write like that, or if we simplify this equation, we can write that. Then we can write J is equal to J0 plus, what is the value of omega m by omega n? What is the value of omega n 1 by omega n? Tell me. What is the value of omega m1 by omega n? We are considering here the value is a.
A.
So we can
Yes,
write
sir.
a square into j1. What is the name of a? What is the name of a?
Gear tooth ratio, sir.
Gear tooth ratio. If there are so many systems, so we have to consider a1, a2, a3. So first, in case of first load system, we consider here the a1. For that, though there is a one load coupled with the motor system with gear, so we consider here the gear tip ratio is a1. So we can write j is equal to j0 plus a1 square into j1. If there are, suppose, m number of system, if suppose for m number of system, what should be the equation? J is equal to j0 plus a1 square j1, then what we write? A2 square j2 am square jm, like that. If we have a
Yes.
system of m number which is coupled with gear, so you can write like that. Have you understand that?
Yes, sir.
Okay. And now I have to erase this because I have to draw, or I have to derive another equation also, because we have to calculate the equivalent parameter. One parameter is equivalent moment of inertia. We have already calculated, and we have to calculate the equivalent torque, load torque also. So we have to erase all this first. I hope you have write all these things in your copies. What we get, one equation is J is equal to J0 plus A square into, this is our one equation. And suppose if we have a efficiency of transmission, that means when we transmit power from a gear, then there should be some losses on that gear. So if we consider the efficiency eta 1, what is the eta 1 is called transmission efficiency. If we suppose that eta 1 is efficiency, transmission efficiency, now can you tell me how much power is transmitted to that load? Can you tell me how much power is transmitted to that load? And what is the formula of power? First tell me, what is the formula of power for the first system? Tell me the formula of power. How much power is there in first system? What is the value of torque here? Tell me what is the value of torque here? The TL0 is the torque. So in first system, the value of power is TL0 omega m. This is the power of first system. And what is the power of the second system? TL1 omega m1 by eta 1. We calculate individual power of the system. So in case of first load, the total load torque is TL0 and the speed, angular speed is omega m. The total power or mechanical power of the first load is TL0 into omega m, and in case of second load or the load which is coupled with or coupled through the gear, the power of that system is TL1 omega m1 by eta 1, because we are giving or we are transmitting the power TL1 omega m1 by eta 1. So the total power of that system is TL. If we consider the equivalent load torque, what is TL? TL is equivalent load torque. TL is the equivalent load torque. So we can write the total power of that system is TL omega m is equal to TL0 into omega m plus TL1 omega m by eta 1. So from that equation we can write the equivalent load torque is equal to TL0 plus omega m1 by omega m TL1 by we can write like that. Can I write? Deepak? So after that, we simplify this equation. TL is equal to TL0 plus A1 TL1 by eta 1. So this is also a or equivalent parameter. It is TL is equal to TL0 plus A TL1 by eta 1. This is our second equivalent parameter. And if there is m number of system, what is the value, or how we can write this equation? If there is m number of system, then what is the value of, or how we can write this equation? Can anyone tell me how we can write that equation? For m number of load, what should be the equation? TL is equal to TL0 plus A1 TL1 by eta 1 plus A2 TL2 by eta 2 An L1 by eta n. You can write for m number of system. Above,
Yes, sir.
tell me what is the equation for n number of system load or n number of load.
TL equal to TL0 plus A1 TL1 by N1
Eta 1. This is efficiency. It is
eta
called
1.
eta 1.
If it's plus E2 A2 TL2 by eta 2 dot 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 AM into TLM by
Eta
eta
n.
M
This is for m number of load, and
N number.
we have we got actually two equation of equivalent parameter. What are these? Tell me. We have got two equation or equivalent equation for, in this case, rotational motion or rotational load. We got two equation or two equivalent equation. What are these? J is equal to, tell me the first.
J naught plus A1 square J1.
Yes, and in case of load torque, what you got?
TL equal to TL0 plus A TL1 by eta 1.
Actually, this is the equivalent parameter. Our topic is our topic is equivalent values of drive parameter. That means we have to calculate the equivalent values of drive parameter. Here, first we consider the load with rotational motion. What we got? One equation is J is equal to J0 plus A1 square J1, and another equation is TL is equal to TL0 plus A into TL by eta 1. Next, we have to move in second consideration, the load with translation and rotational motion. The second case is load with Suppose this is basically conversion system by which we convert the rotational motion to the linear motion. And consider the mass of the system which is mm, uh, move linearly. Consider the mass of that system is m1, and here we use a force of f1, and for this it produces a linear motion or linear velocity of v1. In case 2, what we see that it is load with translation and rotational motion, because the first load is in rotational motion and the second load here with translation motion, and we have a system by which we convert the rotational motion into linear motion. So now tell me, what is the formula of kinetic energy of that system? Now tell me, what is the formula of kinetic energy of that system? Deepak,
Yes, sir.
tell me the formula of kinetic energy of that system. What is the formula for the rotational motion system? What is the formula of kinetic energy of rotational motion system? Half
Half J,
J
half J,
zero
J naught omega m square.
omega m square. And what is the formula of kinetic energy of that system, the linear system? Half, then
mv1 square.
m1 v1 square.
v1 square.
If we consider the total moment of inertia of that system is J, so we can write the total kinetic energy is equal to half J omega m square. We can write that if we are considering J is the total moment of inertia of the system, then we can write the kinetic energy of that system is equal to half J omega square is equal to the kinetic energy of the first system. The kinetic energy of the first system is half J 0 omega square, and the kinetic energy of that linear or say translation motion system is half m1 v1 square. From this equation, what we write, J is equal to J0 plus m1 v1 by omega m square. We can write like that. If there is m number of system, what is the equation for m number system? What should be the equation? J is equal to J0 plus M1 V1 by omega square plus M2 V2 by omega n square plus what Mn M by omega n square. And what about the load torque? And we have to calculate now the load torque equation. So tell me, what is the power of that system? What is the power of that system? To calculate power, we have to also consider here uh, what is the efficiency, or actually transmission efficiency. There we should consider here also a transmission efficiency. Suppose we consider here the one dashed is transmission efficiency. So what should be the formula of power in case of first load? What should be the formula? Because
TL0 into omega m.
omega m, good. And for the next load, which is actually linear in motion, what should be the formula of power? F1 V1 by beta
By
1
eta 1.
dashed. And if we consider the total load torque is TL, then what is the formula of total power? If we consider the total load torque is TL and the system is rotation with omega m, then the formula of the power is TL omega m. So we can write the total power of that system TL omega m is equal to the power of the first system, that is TL0 omega m, plus the power of second system or linear system, which one is F1 V1 by eta 1. By simplifying that, what we get, TL is equal to TL0 plus F1 by eta 1 dash into V1 by omega m. This is the formula. And if there is n number of system, what should be the formula for n number of load system? What is the formula? TL is equal to TL0 plus F1 by beta 1 dash V1 by omega m plus F2 by beta dash equal to 2 by omega n plus plus f n by omega n dash into n by omega. Rahul Kumar, have you understand that? What are the
Yes, sir.
equivalent drive parameters are? Rahul Kumar, Rahul Kumar, Rahul Kumar.
Yes, sir.
Tell me what are the equivalent circuit parameter or drive parameter for any drive system? Which quantity is called the actually drive parameter? One is moment of inertia and another is load torque. So we have to calculate the equation of equivalent moment of inertia and equivalent load torque for rotational motion system, and another is rotational and translation motion system. In first case, what we will get, what we got in first case, what is the equation? Tell me. In case of loads with rotational motion, what is the equation at the or the time? J is equal to J0 plus A1 square J1. And in case of load with rotational and translation motion, what we got? J is equal to J0 plus M1 into V1 by omega m square. And in case of load torque, what we got? Previously what we got? TL is equal to TL0 plus A1 TL1 by eta 1. And in case of here or second case, what we got? TL is equal to TL0 plus F1 by eta 1 into V1 by omega m. Now we have to calculate we have to solve a problem. Suppose Suppose we have a problem or we have a system, a motor drives with two loads. One has a rotational motion and it is coupled to a motor through a reduction gear with A is equal to 0.1 and efficiency of 90%. The load has a moment of inertia of 10 kg meter square and torque of 10 Newton meter. Another load has translation motion and consists of 1000 kg weight to be lifted at an uniform speed of 1.5 meter per second. Coupling between this load and the motor has an efficiency of 85%. Motor has inertia of 0.2 kg meter square and run at constant speed of 1420 rpm. Determine the equivalent moment inertia of that shaft and power developed by that motor. This is our problem. So we have to calculate that. So please calculate and tell me what is the value of J and total power developed by the motor. Based on the previous theory, we have to solve this. Calculate it and tell me what is the value of J. Have you write the problem? Have you write the problem? Rahul,
Yes, sir.
have you write that problem? You have to solve this problem because based on previous theory, you can solve this problem. First, write down which quantity are given in the problem. First, tell me the value of J0. Just tell me what is the value of J0. Deepak, what is the name of the J0? The moment of inertia of motors and fast load system. But here J0 should be the moment of inertia of that motor only because there is no direct coupled load, and you can say here is a motor, then there is gear, here is the system is like that. This is motor and these are the gear. This is first load, TL1, and this is basically transmission by which we actually change the convert, or we can convert the linear motion from the rotational motion to linear. This is conversion system, and this is the mass we are considering here M1. Now J0 is moment of inertia of that system. Now tell me what is the value of J0? Here the J0 value is 0.2 kg meter square. And what is the value of J1?
10 kg meter square.
10 kg meter square. Good. The value of J1 is equal to 10 kg meter square. And what is the value of A1? That means gear ratio is
0.1.
0.1. And what is the value of V? What is the value of V? And we can say V1. What is the value of V1? 1.5 meter per second. And what is the value of omega n? 1420 rpm. You have to convert it in radian per second. So what we should do? What should we do? To convert the rpm into radian per second, what we should do? We have to multiply this by pi by 30. That means 2 pi by 60. value is 148.7 rad per second. Now tell me the equation of J is equal to J0 plus J1 into what?
A1 square.
A1 square. First right, we have to write A1 square. A1 square into J1. After that, what is the equation? After that, what is the equation, or what should be the equation? In case of second case, what is the formula of moment of inertia of the last part? J
M1 into
m1
V1 by
into v1 by
V1 by
omega m
omega m square.
square. So now calculate the value. What is the value of J0? Tell me what is the value of J0?
0.2 kg meter square.
Only 0.2. And what is the value of A1? 0.1
0.1
square.
square.
Then what is the value of J1?
10 kg meter square.
Into 10. Then what is the value of M1? How much mass is there?
1000 kg.
1000. So it should be 1000. Then what is the value of V?
1.5.
1.5. And what is the value of omega M?
48.
148.7. So calculate it
7.
and tell me what is the value of that. Calculate it and tell me the value of that. What is the value of that? After simplifying, what is the value get? Above this is 0.4. And what is the unit of J? What is the unit of J? Tell me what is the unit of J?
centimeter square.
And after simplifying this equation, you get the value is 0.4. Have you got that? Now tell me the equation of load torque. What is the formula? What should be the formula? A1 TL1 by eta 1 plus, because there is no TL0, so the formula is TL is equal to A1 TL1 by eta 1 plus F1 by eta 1 dashed V1 by omega n. What is the value of A1? Tell me what is the value of A1? 0.1.
0.1.
And what is the value of TL1? What is the value of TL1? Here you say that the torque is 10 Newton meter. That means the value of TL1 is 10 Newton meter, and 10. And what is the efficiency of gear? What is the efficiency of the gear? And how much
90.
efficiency?
90%.
90%. That means 0.9. So the value of here is 0.9. Then what is the value of F1? What is F1? F1 is force that has to be given here. What is the value of force? That means mass into acceleration, that is G. What is the value of M? What is the value of M?
1000 kg.
And what is the value of G? What is the value of G?
9.8 meter per second.
9.8 meter per second square. Then what is the value of that? 9800 Newton is 9800. And what is the efficiency of the rotation to transmission system?
85%.
85%. That means 0.85. So here should be the value is 0.85. And what is the value of V? What is the value of V?
1.5 meter per second.
1.5. And the value of omega? Value of omega n?
48.7.
148.7.
0.7.
Now calculate this and tell me the value of that system. Simplify this equation or calculate this. Tell me how much the value is coming. For this equation, how much value is coming? The value should be 117.53. And what is the unit of torque? What is the unit of torque?
Newton meter.
Deepak, tell me what we actually did today. Deepak, just
Yes, sir.
sum up of class. Tell me sum up the class. What actually do today? Sum up the today's class. We actually did today. We have calculate
Equivalent equation of load with translation motion and equivalent equation of load with translation and rotational motion.
and what are the equivalent parameter?
Moment of inertia,
Moment of inertia and another
angular speed of motor, load torque,
load torque.
angular speed of load coupled torque gear, and load torque of load coupled torque gear.
And after getting the equation, we solve a problem and hope you will understand that. So now it is the attendance. Deepak,
Yes, sir.
Rahul Kumar,
Yes, sir.
Priti Kumari, Priti Kumari,
Yes, sir.
Anjali Kumari, Anjali Kumari, Pooja Sharma,
Yes, sir.
Akshay Kumar Prajapati,
Yes, sir.
Avinash,
Sir.
Avinash,
Yes, sir.
Jiaul,
Yes, sir.